I'm Andrew. Let me start sharing my screen. So problem 2 is called moving 1. Basically, this problem says that a bunch of ants are about to die. So these ants are trying not to die. So what happens is each ant chooses another ant to follow. And we have to see if there's like a cycle of ants, basically. So this problem, basically, let's just create a new blank thing over here. Okay, so what it tells us is that for each ant, it gives us like another ant that this is pointing to. So like the ant that it's following. Let's just denote that by an arrow. So basically, it's asking us to see if there's a cycle in this graph, right? Because this we can just represent it by a graph by having each ant like pointing to another ant be represented by an arrow. And if an ant points to itself, then it just doesn't point to anything. So for example, like if this ant like points to this and this ant points to itself, we can just have like no arrows coming out of that. Which means that each point will either have 0 or 1 arrows coming out of it, because again, each ant can only follow one other ant, or it can just follow quote unquote itself. So what it asks us here to do here is just find if there's a cycle. So here's an easy algorithm to find if there's a cycle. Basically, since we know that there's like, let's say ants 0 to n minus 1, you have ants 0 to n minus 1, right? And then these ants, we basically, so we have these n ants here, and 0 to n minus 1. So we can just iterate through this entire list. So we can start with ant 0 and then see whatever path that it follows. So for example, it can just like keep going here and here and here. And this is just going to follow like one specific path, because each ant can only follow one other ant. So it's going to have one specific path. And then in the end, this path is either going to have end at an ant going to itself, or it can go to another ant that's already been visited this iteration. And that would create a cycle. So now this leads us to ask, like, so we can just do this over and over again. For example, when we start with ant 0, we can visit all of these, right? And then we mark them as visited. And then we start with like another ant that we haven't visited before. And then we do like the same thing, do this path, and see if there's a cycle. So that's the gist of the algorithm. So the next question is like, how do we know if there's a cycle or not? So for example, we can have a graph like this, right? Just like going straight, first of all. Like, who knows if there's a cycle or not? And then we start with another ant, right? And then it goes to like another ant we visited before. So then, is there a cycle here? That's the question. Well, in this case, there's not a cycle. But let's say we go like here, 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 and then we make a loop like this, and then there would be a cycle. So it's up to us to figure out how to find the difference between like if there's a cycle or if there isn't. Well, I guess so the algorithm will work like this. So first of all, we have a list of ants we haven't visited before, right? Like 0 dot n, right? Dot n minus 1 initially, right? And then every time we visit an ant, for example, we start with ant 0 here, we would remove 0. And then we visit this ant, let's say like ant 5, then we remove 5. And then like, let's say 2, then remove 2, and then so on and so forth. We remove all the ants that we visited before, basically. So that's like a list of the ants we visited before. But the thing is, we also have to determine if we visited an ant this iteration or not. And I'm saying like this iteration as in like an iteration is like when you start with like a new ant. So let's say we start with 0 and then we go all the way to like the end of its path until like the ending ant either goes to itself or goes to an ant we visited in the current iteration. That means that so when that ends, that's just one iteration. We remove all these from the not visit from this array. And then, however, if we visited this iteration, for example, like the first iteration, we'd visit all of these ants. If we visit one of these, we have to mark it as like visited this iteration. And then if we visited again that iteration, like we can go check, oh shoot, we visited that again. And then we have to realize that that's going to create a loop. If we visit an ant that we previously visited this iteration, that's going to create a loop. However, let's say we're on like a different iteration, right? Let's say this is the first iteration. We move past that, right? And the second iteration starts with this ant. Then if we visit an ant that we previously visited in a different iteration, then that's still not going to be a loop, because for example, we have this thing, right? We have this line, and then this eventually visits this ant, which we previously visited, but there's not going to be a loop. So that's basically how this is going to work. So let's put this into coding now. Again, what I explained just now is like kind of a pseudo solution. So we're gonna have to like actually trim out the details of how it works. So let's begin. So first let's create buffered reader input equals new buffered reader new input stream reader system.in. Let's just get all of this done with. And then the first line is just going to be C, which is going to be test cases. So int C equals input integer dot parse int input dot read line. Okay, so now we have C. Next of all, we just create a for loop going ranging from I to C. Boom, boom, boom. Okay, and then now for each of the C cases, first of all, we take in n. So int n equals integer dot parse int input dot read line. Now the next line will contain n integers. So when we now have string, we create a string tokenizer to parse the integers in the line. So string tokenizer st equals new string tokenizer. I cannot type. Input dot read line. So what we do here is that each of these will represent like the ant that ant I follows. So basically, let's just create an array. Int follows equals new int n for int j 0 to n. Follows j is just going to be integer dot parse int st dot next token. Boom. And so what's next? So let's go into the actual meat of the solution. So again, remember that we focus on 3 sets of points. First of all, points that we haven't visited before, points that we visited this iteration, and points that we visited in a previous iteration. Again, like interactions between like those 3 sets of points. For example, like if the next point is like whichever set the next point is in matters. So we have to store these 3 different sets of points. So let's think about like how we can store this, because with each set we have to be able to like easily like remove or add a point, or to find or just to like determine if like some random point is in there in like at least in like less than O of log n time. And there's one main data set that does that, which is the hash set. Basically, if you have a hash set, you can add or remove any point in O of 1 time, and you can determine if a point is in there in O of 1 time. So let's create a hash set. So this first hash set not visited just represents the points that we haven't visited before. So like again, initially it would be all of these. So let's just for int I j equals 0, j less than n, j plus plus, not visited dot add j. So now this contains, we haven't visited anything yet. Now our second hash set is if we visited this iteration. So we can just do like this iter equals new hash set integer. So this will determine if we visited this iteration, because again, if we visit a point that we visited in this iteration, then that's going to create a contradiction. That's going to be the only time where there's a cycle. And then finally, we can make one for like things we visited in previous iterations. New hash set integer. Of course, like it isn't actually necessary to make this, because the elements in here are just gonna be the elements not visited or this iteration. But I think it's still pretty helpful. Like it'll make things a bit simpler. Let's see if it's necessary. So let's start making our main loop now. So what our main loop is gonna do in this problem is it'll determine if it'll go through every single thing in not visited, right? So I guess we can do like while not visited dot size is greater than 0, because our loop just wants to visit through every point. When we visit through every point, we're done. So yeah, so we can let, first of all, okay, so we can Actually, I think, yeah, we should instead do this. If not visited contains J. Right. So we should do, okay, so we have it like this, right? So what we're gonna do here is, first of all, like again, this just does the same thing, but except it actually tells us like which element we're looking at. So then let's say we start at some point, right? Let's say start at point 0, and then we would go to this point, right? And see if it's been visited this iteration yet. If it hasn't, then we're chill, and we can just keep going. And when a point either A hasn't when A like has like visits itself, like follows itself. So like, yeah, either follows itself, or it follows some point visited in a previous iteration, then we're able to just like move on to our next iteration. Like that's going to be the end of the iteration. So let's put this into code. So first of all, int temp is just going to represent what ant we're currently on. So again, initially it'd be just ant j, because that's what we start with. So then we can just do a while loop. Like while, for example, while temp is not equal to temp. It's just, again, while like our current ant doesn't follow itself. So there's going to be a few things you have to do here. First of all, we have to see again if point temp has been visited this iteration already. So wait, at the end of here, by the way, we're going to do temp equals follows temp. And this is just to make sure like we go to the next point, that like, for example, like the variable that has 0 is going to go to the variable, but like that represents whatever index of point this is going to be in, and then this, and so on and so forth. Then we have over here, if we visited this point in this iteration already, so if this iter.contains temp, then our answer is just going to be 0, because then there'd be a cycle. So we just system.out.println 0, and then we just break. Well, to break this for loop, we have to do j equals n as well. So let's just do that, because this break thing breaks the while loop, but then we're still in this for loop itself. So doing j equals n can just break us out of the for loop. Then we also have to have a Boolean variable. Basically, this is representing, we only print out 1 if we don't print out 0 at all in any of these states. So we have to we have to have a variable to store like if we printed out 0 or not. So let's just let that be bad. So if we print out 0, then bad equals true. So in this case, like if we don't print out 0, then we print out 1. Now let's see. So over here, so far we've done 2 cases. First of all, if this temp, the one we're currently in, is in this iteration, and second of all, if it's been visited this iteration. Now the second case is if it's been visited in a previous iteration. So like else if visited.contains temp, then all we would do is break, right? Now let's look at the other cases. So what we would do is, let's say that we don't break in any of these cases, right? So basically we haven't visited this point before. Then what happens is that we would have visited this point, right? So like, since we're visiting this point, it can't be a point we haven't visited before. And now we have to add it to like the list of points that we visited this iteration. So this is it. Because again, this is going to be if we visited this iteration, if we visited in a previous iteration, and wait, this is supposed to be pre-iter. I got the what's it called? The variable name wrong, my bad. But yeah, a previous iteration. So like if we visited in a previous iteration. So yeah. Anyways, so that's going to be just like finding like the end of where we finding the end state, like our end state. But now, as we're at the end state of an iteration, we have to, since we ended this one iteration, we have to add all the elements in this iteration in the list of points we visited this iteration to the list of points we visited the previous iteration, because now, like, since we're done with this iteration, it's not the current iteration anymore. So what we're gonna have to do is we're gonna have to, after the while loop, we're gonna have to do previous iteration to add all this iteration, because again, yeah, we just add all the points we visited this iteration to the previous iteration. And since like the new iteration, after this iteration, we haven't visited anything yet, we can just clear. So this should be a complete code now, because again, we've gone through our entire algorithm, like we've checked every single point, and we've done the 3 cases. If we visited it, if we haven't visited it, visited in a previous iteration or visited in this iteration. So we did all that. Let's see if it works. Oh, there's a run. Oh, yeah, I forgot to. Right. Okay, let's go to. I should probably test this in run code. That is a good idea. So there's a runtime error on line 27. Let's see what's up with that. So while follows temp is not equal to temp. So let's see what's up with this. If anyone has any ideas on what the runtime error is, feel free to speak up. But let's see what is up. So it's time for a little bit of debugging. So temp has been defined, has follows been defined. Yep, follows has been defined. So, okay, we've added. Oh, what happened is over here, I forgot to subtract 1 because this integer would parse in st.next token. This basically says that the element that follows the ant that 0 follows is 1, the ant that 1 follows is 1, the ant that 2 follows is 2, the ant that 3 follows is 3, and so on and so forth. But the thing is, the ants in the input are going to be 1 indexed, not 0 indexed. So we have to subtract 1 from each of these follows things to make sure there's 0 indexed. So let's run this code and see if it works. And it does work. So again, that's something really important to know. Like in the test case, in the sample cases, like in the sample input, if it's going to be 1 indexed or 0 indexed. So I think that's just one really important thing to take note of. But yeah, as you can see right now, all 3 of our test cases are correct. So I think that's enough for this problem. If you have any questions, please let me know.